So here we are trying to solve a question which came in 2022 JEE Mains. In this question, what's given is there is a matrix which is given, and then there are certain conditions which are given that M is defined as summation of a raised to the power 2k, and that k is varying from 1 to 10, and n is represented as a raised to the power 2k minus 1, and then there is a condition which is also over here, or rather this is a problem statement that we need to find out what is m into n square. That is what is we are trying to find out. So in this case, we first need to find out what is m, then we need to find out what is n, then we need to find out n square, and then we sort of multiply, then only we'll be able to decide what sort of matrix it is. So let's start with this m first, and then we'll come to n as well. So let's look at what is m. So m is, if you just try to expand this m and then try to write this will be nothing but a raised to the power 2 plus a raised to the power 4 and a raised to the power 6, and it goes up to a raised to the power 20. This is what it is. So we need to find out what is a square, a to the power 4, and so on and so forth. So let's first find out what is a square. So we'll have to do a into a to find out a square. And for that, we need to multiply this matrix, which is 0, minus 2, 2, 0, with this 0, minus 2, 2, and 0. Now, we know the rule of multiplication. Rows elements would be multiplied with columns element. So we'll multiply 0 with 0. So let's write it down for once. So 0 into 0 plus minus 2 into 2. So this is first element is done. Now let's go to the second one. First row into second column. So which is 0 into minus 2 plus minus 2 into 0. Then row into column again, 2 into 0 plus 0 into 2 and 2 into minus 2 plus 0 into 0. So what do we get from here? What we get here is we get minus 4 here, then we get a 0, then we get a 0 here, and then we get a minus 4 here. So these diagonal elements are same. So what I can do is I can also take out minus 4 out. So if I take minus 4 out, this will become 1, 0, 0, 1. So why did I do it? Is because this is looking like an identity matrix, and maybe after this things will become simpler. So what we have got here is minus 4 into identity matrix. So which is a 2 by 2 matrix. Now for the next one, if I'm looking at a raised to the power 4. So for that, first I need to get to a raised to the power 3 also. So a raised to the power 3 would be nothing but basically a square into a. Now what is your a square? A square is nothing but minus 4 into identity matrix. And then if it is multiplied with a matrix, then I'll get minus 4a, because I into a would give you a itself. Identity matrix multiplied to this matrix will return you the same matrix. So this is what we have got. So let's get to a raised to the power 4, because that is the next thing which you want to know. So a raised to the power 4 would become nothing but a raised to the power 3 into a again, which will become minus 4a. And then next thing we know is that this is going to be a again. Now this will become 4 into a into a. Now this a into a is nothing but a square, for which we got minus 4i again. So what we have got here is minus 4 into minus 4i, which will give me nothing but minus minus plus, which is 16i square, or I could also write it as minus 4 square into I. And why is that I'm doing it is because again, there is looking like a pattern which is emerging. A square is minus 4 into I, a to the power 4 is minus 4 square into I. We'll check for a raised to the power 6, and then we will know that what is the pattern which is coming in. So let's go to a raised to the power 5 also. So what is a raised to the power 5? A raised to the power 5 is nothing but a raised to the power 4 into a, which is gonna give me 4 minus 4 square into I, and then into, again a is here, then we know that I into a would give me a again. So this is also gonna give me minus 4 square into a itself. So this is what we have got. Now a raised to the power 6, and this is where we'll stop after this. We know the pattern, what is emerging out of that. A raised to the power 5, which is minus 4 whole squared into a into a. So this is for a. So minus 4 whole squared into, and this is, we know that this is minus 4 into I. So this is going to give me minus 4 into I. And then eventually I've got minus 4 raised to the power 3 into I. So I've got a series going. Let's put this over here and see what we have got. So we have got something like a square was minus 4 into I. So this is minus 4 into I. And then we have got minus 4 square into I. And then the next one is minus 4 to the power 3 into I. And then the last term will be minus 4 raised to the power 20 into I, of course. Then I can be taken out, and this would sort of become GP itself, minus 4 into minus 4 square and up to 20 terms. And then this is something we can write it as I into, this is A. I mean, we know the formula of a GP is summation of a GP, which is A into R raised to the power n minus 1 upon R minus 1. So we can write A into R raised to the power. So R is again minus 4 itself, as we can see if you divide this by this. So minus 4 raised to the power 20 minus 1 divided by minus 4 minus 1. So what we have got is 4 by 5, and then this will be minus 4 raised to the power 20 is 4 raised to the power 20 minus 1 into I. That is what we have got. This is what is my M. So we have got M over here, right? Now let's check what is N. So let's talk about N. So N, I'll write it here, but we will calculate. So N is, if you write A equals to 1, this is A. Then it is A cube. Then A raised to the power 5. And then the last term would be A raised to the power 90. So these as well we have calculated actually. A we have calculated, and A cube, if you look at A cube, this was minus 4A. So we'll just write it as minus 4 into A. And then the next one is A raised to the power 5, which is minus 4 square into A. So here too, there seems to be some sort of relationship going. So here it's minus 4 to the power 0. So you could just say this is minus 4 raised to the power 9 probably. So this is to A. Then you can take A common from here, and then this will become 1 minus 4 plus minus 4 square, and then up to 10 terms again. And this as well can be simplified as what? This can be simplified as A into A. Again, this is a GP, which is first term is A, and then common ratio is minus 4. So A into R raised to the power n, which is minus 4 raised to the power again 10. So here too, I'm sorry about that, but I think here the term should be, this should be 10. This should be 10. Because this is not up to 20 terms, but rather it is up to 10 terms. So 4 raised to the power 10. So here too, minus 4 raised to the power 10 minus 1 divided by minus 4 minus 1. So what we eventually got here is, that we have got here is 4 raised to the power 10 minus 1. And then this is going to give me upon 5 into A. Now, they don't want n. Here we want n square. So what will happen to n square? Because now here itself we can write, as you can see already over here. So what will happen to n square? If I'm looking at this as some number, which is a constant, which is 4 raised to the power 10 minus 1 by 5. And if I'm looking this as A, and again you got to write 4 raised to the power 10 minus 1 by 5 into A. So this will become whatever this number is. This could be a square, 4 raised to the power 10 minus 5 whole squared. And this will be A into A again, which we know is what is going to happen. A into A is, we have already calculated, this is minus 4 square into I. So this will become 4 raised to the power 10 minus 1 whole square upon 5. Basically, whole thing is whole squared actually into minus 4 square into I. So you could write it as 16 by 25, something like that. And then 4 is to the power 10 minus 1 whole square into I. Now we've got m, we've got n square. So m and n square is what we have got. So this is what is your m, which is 4 by 5 into 4 is to the power 10 minus 1. And then you've got I here. And then you've got this big number, which is 16 by 25 and 4 raised to the power 10 minus 1 whole square into I. So whatever this is, this number, this is something like a constant, another constant. So we just call it a constant. And then you've got I into I, right? What will happen? I into I, this will become I square. So from here on, we could just have written the constant. I just wrote it, but you could have just avoided writing so many big number. And then we could have just written. So this I into I will again return you an I itself. So K into I, right? So this is, we know that identity matrix will be a symmetric matrix, and that is fine. But when we multiply with K, then of course it is not remaining an identity matrix. What it is actually becoming is this K 0, 0K is what it is becoming, which is more like uh, what you call a symmetric matrix, but it is not an identity matrix, right? So we can say that is because of this reason. It's a non-identity symmetric matrix, and this is what will be your answer. This is not a skew symmetric matrix. It's a symmetric matrix. So it's not. It is also not right, and it's not an identity matrix because had there not been any constant k over here, which is this big number, then we could have said it is an identity matrix. But it is not sort of getting cancelled out, but rather it is becoming such a big number, right? So because of which reason, this is a symmetric matrix, but not an identity matrix. And because of this reason, this will be your answer. All right. Okay, so this is what it was. Thank you so much for watching.